This is question number 3 in our EGD preparation paper for 2020, and we have an analytical mechanical drawing where 4 views of a crank disc with a title block and some questions in a table have been given to us. This is the block of all the questions, and there are the 4 views. That's view 1, 2 and view 3 on top, and then there's a view that has been taken out based on that cutting line over there. Let's look at the questions. Of course, you will have to find all the answers to these respective questions from the views given. Question number 1, who approved the drawing? And that's going to be Peter, right? And the SI unit used to produce the drawing, that's going to be millimeters. So all the dimensions here are in millimeters. Question number 3, which drawing method was used to create these drawings? You will find the answer here in the title block, and that's going to be the CAD drawing method which was used. Okay, there it is, right there at the bottom. That's a drawing program, AutoCAD 2015. Okay, and then we go to the next question. What is the web address of the design company? And that you're going to find here at the bottom as well, www.precision.co.za. You're going to write it in there. How many sets of drawings are there, and how do you determine that? You will have to go to your title block over here, and you are going to find that information. If I could just get this out of the way. Right in the space it tells you here, drawing sets 2 of 2. So there would be 2. That's the answer there. What is the feature at R called? So we'll have to go to R. Just before we go to R, we're just going to do number 6. What is the tolerance allowed on the dimensions? The word tolerance, once again, most of the information in your title bar here. It says here, unless otherwise specified, tolerances on dimensions are plus minus 0.35, and that is what you're going to write in that space there. And then coming back to what is the feature at R called? So you will have to go to R, and you're going to find R on your drawing. If I just move this over, we are going to look at R here. If we bring it down for you to see, that is R over there. It's that sunken area over there inside. That serves as the part where the head of the bulb goes through. So that is a spot face, S face, spot face. You're also going to find that these circles here refer to the spot face. Okay, there it is, S face, and they tell you what the dimension is there. Then we go to number 8. What is the size of the arc marked at S? So once again we go back here, this arc here, which is basically a fillet as we would call it. What is that? Right? So we will have to find what that is. That is R5, radius 5. And how do we know that? I don't tell you there, but if you go to your title bar, it says all unspecified radii are 5, meaning that wherever you are going to find corners like these where no dimension has been given, you must regard it as R5, radius 5. Alright, let's go to the next question. We've got that one. Number 9. Determine the dimension at T, and we're going to determine the dimension at U for number 10 and the one at V, 9, 10 and 11. Let's go find those on the drawing. So we need T. Okay, if you scan over your drawing, so that is T over there. So very important, how do you determine T? So if you come across this section here, right, you will see that there's a 40 there for the whole thing. Okay, so that part there, which is 14 over here, right, and that part is linked to this part which is over here. Okay, and it cuts through this part over here, so that there refers to this over here, so that's going to be 30 over there. For T, T will be 30, refers to this part here. You can see it cuts here, so it refers to that section over there. And then we have U. So we got to look at U. There's U, and U refers to that little arrow from there to there, which basically refers to a radius point here. How do you determine that? If you take this out like that there, the whole thing from here to here is 12, but you only need half, which is going to be a radius 6. There it is, right? It's going to be 6, and I just want to point it out to you. That's radius 6. And then we have V on your drawing. You're going to have a look at V now. I just want to centralize this drawing. V refers to that part over there, so if you scan it down, it's going to refer to this circle over here, and you will see that that circle is 40. So that's how you get your 40 as an answer for that dimension. What change, number 12, did Keanu recommend? Right? What change did he recommend? So we go to the title bar. There's Keanu. He made some sort of revision, and he inserted a keyway on the drawing. He inserted a keyway, which is that there on the drawing. That is what he recommended. Number 13, what is the purpose of the change that Keanu recommended? That's number 13. Now the purpose of that keyway, it's very important. It secures momentum, and I want to explain this. It secures momentum between the shaft and the disc. Alright? Now, if I must just explain to you what it means. If you have a disc, which is a circular shape, and you have a shaft where the disc is moving on, then you have a key that runs like that. It goes halfway into the disc and halfway down in the shaft. And that key is that little square little section that perfectly goes into that there, which locks both the shaft and the pulley or wheel or disc, and that secures the momentum between the two components, which basically means that the one turns that way, the other one will turn that way as well, and vice versa. Okay, then number 14, what type of section is shown on view 3? What type of section is shown on view 3? Now you go to view 3, right? The section that they have here is this section here of line B, and I want to point out that view there, that's, sorry, let me just get to that. That section in view 3, which is here, comes from this B cutting line that we have there. B cutting line like that there. See, there's B and there. And that you call, if it runs like that, it's called an aligned section. It's called an aligned section. What type of section is shown on view 4? That is view 4. It has been cut by C, the line C, and it has been taken out, so it has been removed. So it is called a removed section, which you have there. What does the letters PCD stand for? And I want to look at PCD because it says here 4 holes, 8 diameter, which are these 4 holes, 8 on a 72 PCD. 72 PCD is the circle which all the holes are situated on. That is PCD from year to year. Pitch, circle, diameter. Pitch, circle, diameter. Okay. How many diameter 8 holes need to be drilled in the disc? And that's simple. 1, 2, 3, 4. That's your answer there. And then lastly, in the space provided here, we need to draw the proper symbol, and please make sure that you understand that symbol. So that line is given to you. This is how you start. Draw a little cross there, and a long line here, and a long line there. That's the first thing. Then you draw a small circle around that cross there, and then a big circle around that cross there. That's where you start. And then you move any distance away. You draw a line like that, which is basically the length of that circumference to circumference, and another line any distance away, which is basically the length of that diameter there. And all you do is you connect the line like that. The smaller line first, and the bigger one at the back, and that forms your symbol, which you are going to get 4 marks if you draw it correctly. And of course, that's drawn freehand. This concludes the question number 3.